Hey everyone, I want to talk about lipid absorption. But before we talk about that, we need to talk about lipid digestion. For that, I want to go to the PowerPoint briefly. Okay, so let's start with discussing what is a lipid. Is it hydrophilic or hydrophobic? It's hydrophobic, right? And what is most of our body? Hydrophilic, hydrophobic? Well, for example, the blood is very hydrophilic, right? And and the chyme in our stomach is hydrophilic, and then as it travels into the duodenum, still hydrophilic. So what we need is a way for our lipids to travel in this hydrophilic environment. And what we have is the bile salts. See the steroid nucleus? It has a hydrophobic region that can interact with the lipids, and a hydrophilic region here that can interact with the watery environment. All right. So let's keep that in the back of our minds as we discuss this. All right, in the stomach, we have mechanical digestion, but then we also have gastric lipase that will remove a fatty acid from the triglycerides. So remember how, back from chapter 2, the fatty acids have a glycerol backbone and 3 fatty acid tails coming off of it. Maybe a bit like that. So here, the gastric lipase is going to remove one of those fatty acids. So we end up with diglycerides instead of triglycerides. Tri being 3, like a triathlon, 3 events, diglyceride, 2 fatty acids. And then the one that's pulled off is just a free fatty acid. Right, and then down in the small intestine, we have the bile salts that will come and surround. Here we go. It's come and surround the lipids. At that point, we call them emulsified. They're emulsified lipids. Then pancreatic lipase will come and will digest them further. So you have monofatty acids, or monoglycerides, sorry, and free fatty acids. Monoglycerides, free fatty acids. So you're going from diglycerides to monoglycerides. In the stomach, we went from triglycerides to diglycerides. Now we're going from diglycerides to monoglycerides. But these monoglycerides are still lipids, right? They're still hydrophobic, and they're still in a hydrophilic environment. So what happens? How do they cope? These bile salts come back now and surround them. And this is called a micelle. Now I want to go back a little bit and say the gastric lipase, that makes sense, right? Gastric lipase in the stomach. Lipase being lip, like lipid, and ase as an enzyme. Gastric being stomach. Now here it's called pancreatic lipase. Is it taking place in the pancreas? It's not, is it? It's in the small intestine. But the enzyme is made in the pancreas. And that's why it's called pancreatic lipase. All right, so our final product here we're ending with is a micelle. You've got monoglycerides, free fatty acids, and the bile salts surround it. You've got a micelle. And that's where I'm going to pick up here for the lipid absorption. We have a micelle. You have your monoglycerides and your free fatty acids surrounded by bile salts, or micelle. The micelle escorts the fatty acids and the monoglycerides down here to the cell membrane, where, what do you think? Do we need some type of facilitated diffusion, or can they pass through the membrane? They're hydrophobic, so they can pass through the membrane. All right, so they pass through, and what happens when they get in? They get reassembled. Isn't that funny? We spent all this time taking them apart, and now once we're into the enterocyte, the small intestine, the simple columnar epithelial cell, once we're inside, it's going to put it right back together. Now, what do we do with them? Because we need to get them to the rest of the body. but they're still hydrophobic, aren't they? And our blood and the body is still hydrophilic. So what they do is, what the cell does is it coats it in a protein coat, an apoprotein coat, in fact, apoprotein. And once that takes place, it's a chylomicron. It's really quite large at that point. And the cell sends it out by exocytosis. And what do you think? Does it go in the blood? Because it now has this coat, right? So it can interact with watery environments. It can travel through watery environments, but it can't get in the blood because the chylomicron is so large it can't get into the blood vessel. So it goes into a lacteal and travels up and enters into the through the thoracic duct. So this one is different than all the others because the carbohydrates and the proteins, they're all going to the liver first because they got in the blood. They can get into the blood. But the lipids go into the lymph, so they're not headed to the liver first. Does that make sense? Let me review it. Let's go back. We had, in the stomach, you had gastric lipase, right? In the small intestine, we had pancreatic lipase. Gastric lipase took it from a triglyceride to a diglyceride. Pancreatic lipase took it from a diglyceride to a monoglyceride. And then the bile salts surrounded those. And you had a micelle, which escorts them to the plasma membrane of the enterocyte, small intestine cell. And once inside, but they can just diffuse right through, and because they are hydrophobic. And remember, we have the plasma membrane with the polar heads and the fatty acid tails. And the fatty acid tails, fatty acids can just diffuse right through. All right, so once they're inside the cell, they get reassembled, coated with an apoprotein coat, which forms a chylomicron. The cell sends it out by exocytosis, and it gets into it can't go in the blood, too large. But remember the mini valves that can open in the lacteal? So it gets into the lacteal and is returned to the blood at the thoracic duct, which is different than carbohydrates and proteins, which go to the liver first. This is not. It does eventually make its way, but first getting into the thoracic duct. All right, everybody? Let me know if you have any questions. Thank you.